This is for my students learning about linear regression. What you need to do is open up Desmos and then click the plus sign over here on the side to begin entering a table. In this table, we're going to put in some data. So I'm just going to make it up, some decimals, keep it, single digit-ish numbers like 4.2, 5.3, 5.6, 7.2, 8.4, 9.1. Those are my X, independent, whatever. In fact, if I wanted to, I could probably go call this like time, but let's leave it as X1 for now. In the other column is my other variable, my dependent quantity, and I want some double-digit numbers, and I'm going to keep them roughly in the 20s, just because I don't want these to be too crazy. So like 21.1, 21.4, 22.5, 23.7, if I can get, enter every time. Oh, 2252, okay. 23.5, 23.7, and last of all, 24.1. None of those points are showing up on the grid, so you can do a couple of things. First of all, you can kind of like swipe and click and zoom, dragging the screen around, and there the points are. But something else you might want to check out, which is actually under my face, let's get that out of the way, is to click the wrench. And when you click the wrench, you can mess with your X and Y axes. Since none of my numbers here go beyond 10 or are negative, then I want my interval, think tails plus, this is the I in tails plus, to go -1 to 11. The -1 positions the x-axis visibly on the screen, and then 11 because, it's a little bit bigger than 9, a little bit bigger than 10. There's enough space there. See, move that out of the way. You should also probably consider your y-axes, and I do want to make my x-axis on the bottom. Did I say x-axis at first? I meant y-axis, x-axis. Come on, you know better. I want to make that visible, and for the same reason, I'm going to go to like -2. Therefore, it's now visible here, and I have my points, all 6 of them, plotted. Now let me move my face to the other part of the screen. Because in order to write a linear regression, remember that we've said a linear regression is a line that looks like y equals mx plus b. And this is how Desmos can do that work for you. y1. It takes the y coordinates and it understands we want a list. Now we're going to use the tilde, which is squiggle. It's shift and then the number next to the 1. Okay, so shift tilde. See that squiggle pop in? You're going to need to type that. Now, a linear regression has the structure of mx plus b. So I'm going to go m times x1. And it's already trying to draw the perfect least squares line of reflection, or line of regression, through the points. But we need a better y-intercept. So I'm going to go plus b. Down here, if you can see them on my screen, is m equals 0.6278 and b equals 18.5551. Those are the slope and y-intercept that make the best perfect line that goes through the points. Some other information that you need to know is this r squared value and this r value. That's our conversation around what's called the correlation coefficient. If those decimals are close to the number 1, it'll never go over a 1. But if they're like a percentage of accuracy, how much of the data, how much variance of the data is explained by the line of regression, and we're really high, around 90-95%. We need also one other thing called a residuals plot, and so I'm going to click this option here, and what that does for us is it shows this scatter directly below each point is the space, how far away every data value is from that actual line of regression. And if there's some sort of waviness, like randomness in this scatter plot down here, we have a perfect model, statistically accurate, that describes the relationship between whatever my X choices were and my Y choices. If this happens to be time and this is money, then there's definitely a linear regression relating the time and the money from our quantities. There you have it. Thank you for your time. This is how you create a line of regression for a set of data. See you in the next episode.